All right, so how will you do this? I'm not talking about by hand, yeah? Okay, by looking at this simultaneous equation, you have three methods. One is by hand, actually by hand substitution, by hand elimination. Yeah, I'm not interested for this. Let's say by calc, yeah. So by calc, if I don't do by calc, what can I do? I need to sketch it. So I need to rearrange to make y as a subject. So method 3, so rearrange to make y as a subject. So 7y equals 6 minus 3x, y equal to 6 minus 3x over 7, and then 6y equal 12 minus 4x, and then y equal to 12 minus 4x over 4. You can simplify. All right, so which means what I can do over 6. Yeah, so we can do sketch in here. Let's say I want to delete everything. Yeah, if I don't want this anymore, I finish these questions. Or you can open up a new page or delete everything. Yes, okay, delete that and zoom standard. Go back to original. So what I do is type into equation, graph it. Yeah, so which means you go 6 control fraction. Wait. You got 6 minus 3x over 7, enter 1, align, and then tag another one is 12. Minus 4x divided by 6. Yeah. Enter. So I can find out the intersection. Yeah, find the intersections. Menu, graph analyze, intersection, left bound, right bound. Oh, I finally got the intersection, which is a bit time consuming. Agree? Yeah. All right. So instead of this, what can I do? And why I teach you the matrices? That's why I want to use a very useful program. This is actually a bug for not using the solve. It's called RREF. Okay, it's quite useful. But first, to use this, you need to convert this into a matrices first. So to convert it into a matrix, the requirement is they both must be in order. XY constant, XY constant. So they are both in order. So I can write 3, 7, 6, 4, 6, 12. Does it make sense? Yeah. So what I do is RREF of this matrix. RREF of this matrix. So you do the calculator. Go back to this one first. Where can I get RREF? You can type it. RREF. Okay. Or I forgot the name. Menu. Instead of typing it, it's in the matrix. Menu 7. Can you see the reduced row? This one. The menu 7.5. Menu 7.5. RREF. Same thing. A matrix. This time, what I want a number of row 2 by 3. I want a 2 by 3. So I type in 3, tag, 7, tag, 6, tag, 4, tag, 6, tag, 12. Enter. Ta-da! It gives me the answer already. The left-hand side, this can only be the answer if the left-hand side is an identity matrix. 1001, identity. This is called identity. Then you got these two numbers. This is quite useful, RREF for you. if you're holding a graphic calculator. Yeah, no, this one's inverse norm, and then double out here. Solve two equations.
Yeah, inverse norm, you can't do it with the constant.
This is no constant.
Yeah, but you can't put inverse normal inside the double area.
No, two steps.
Yeah, yeah, that makes sense. Yeah.
Okay, understand? All right, then the next one. With me? Yeah. Of course, you know me well already. Yeah, I won't give you exactly the same questions. Then the next one, which I got a new skill. Let's practice this double REF. So which means the next one, yeah, we got this one, double REF, and then you got square bracket 2, 3, 6, 4, 6, 12. Okay, let's see what happened. Calculator, double REF, open bracket, matrices in here, another 2 by 3. Okay, so 2, 3, 6, tag, yeah. 4, tag, 6, tag, 12, enter. You say, hey, what is this? All right, you say, huh? Just now, the answer is not 3 and 0. I told you already, this can only be the answer when the left-hand side is called identity. Identity matrix, which means these two diagonal is 1. The rest is 0. Only the diagonal, this diagonal is 1. And everything else 0. That's called identity. So this is not. So why? How come? What's going on? Yeah. All right. So for this one, why? How come? Yeah, because I just told you I will show you in here. So the answer who give me, what's that? 1, 3 on 2 and 3. 1, 3 on 2 and 3 and 0, 0, 0. Yeah. So can you say if the bottom one is 0, which means this let's say the answer, yeah, this is x. This first row represents x, the second row represents y, yeah, for this answer, if this is the answer. So this is too linear, because how many different ways to get too linear? 3. If the linear is like this, which means they have one unique solution, and which is this example. Yeah, you got the answer already. So this is, you need to gain some context as well. And then it also can draw two linear if they're linear, parallel to each other. You can also draw two linear if they're on top of each other, which means this is called no solution, because we're finding the intersection, yeah, no solution. And this one is called infinite solution. Okay, infinite solution. No solution and infinite solutions. So in an equation point of view, if you got two equations, for unique solution is as long as the gradient is not the same. Okay, like two lines have different gradient, you got unique solutions. For no solution, as long as the gradient is the same. For infinite solution is as well, because they are actually parallel. For infinite solution, but they're parallel on top of each other. Yeah. The second one is if they're parallel and the y-intercept is not the same gradient, different y-intercept, parallel. Same gradient, same y-intercept on top of each other, infinite intersection. Does it make sense to you? Yeah, this is the theory part. You should understand this already. Then in a matrix point of view, if I convert this into matrix, this talking about determinant. So if the determinant is not equal to 0, then which means it has unique solution. If the determinant is equal to 0, then which means either one of these. So by looking at this equation, can you see I just double this double become 4, this double becomes 6, this double becomes 12. So which means these two equations is like exactly on top of each other. That's why you got so many. So next time when you use double EF, we come with this situation, which means it can have so many x-intercept. So that's why y in here, the whole row is 0, which means y can be anything. So let's say K. And X change accordingly. X change accordingly, which means this is X, yeah. X plus 3 on 2y equal 3. So Y can be anything. X change according to Y. So X plus 3 on 2 times K equal 3. So X is equal to 3 minus 3 on 2K. So which means one of the coordinate is when K equals 0, then Y is 0, then X become 3, one point somewhere here. And the next point, when K equals 1, then the Y change, the X change accordingly. Do you understand what I'm talking about? Yeah, so next time when you see a double REF, you got a last row is 0, don't panic. If you don't see 0, that's good, you can get the answer. Okay, yeah, understand? All right, if yes, this is a 2x2 linear. Yeah, you may say, I can do it by hand. Why I need to learn this? Yeah, so ugly, so annoying. So let's have a look for question 5 for me, please.